I was about 10 years old, a story was going round school that Coca-Cola was so bad for your teeth that if you put a tooth in a glass of Coke, it would dissolve overnight. So when a tooth of mine fell out, I thought it would be fun to watch this happen. I left the glass overnight, then all day, and then a week, and the tooth still wouldn't dissolve. Now this should have told me something. If I'd asked the kids at school how they knew that a tooth dissolved in Coca-Cola, they probably would have said they'd heard it from other kids, and the other kids would have got it from other kids. And I would have thought, well, how the hell does anybody know? It was only years later that I learned the key to examining and debunking the floating pieces of fatuous information. Just ask the question, how do you know? Or to put it more specifically, what's your source? How do we know whether to trust the information we get? And where can we go to check it?
You know, interestingly enough, it harks back to the early Persian Empire, about 500 BC.
If you've ever fallen for this kind of barroom wisdom, don't worry, so do a lot of journalists.
Science is constantly producing new studies, as you would know if you've ever watched TV.
A new study shows how sugar might fuel the growth of cancer.
A new study shows late-night snacking could damage the part of your brain that creates and stores memories.
A new study finds pizza is the most addictive food in America.
A new study suggests hugging your dog is bad for your dog.
A new study showing that drinking a glass of red wine is just as good as spending an hour at the gym.
What? There are now so many studies being thrown around, they can seem to contradict one another. We've seen studies about coffee that claim it may reverse the effects of liver damage, help prevent colon cancer, decrease the risk of endometrial cancer, and increase the risk of miscarriage. All that ridiculous information can make you wonder, is science bullshit? To which the answer is clearly no, but there is a lot of bullshit currently masquerading as science. Not all scientific studies are equal. Some may appear in less than legitimate scientific journals, and others may be subtly biased because of scientists feeling pressured to come up with eye-catching positive results.
My success as a scientist depends on me publishing my findings, and I need to publish as frequently as possible in the most prestigious outlets that I can.
Now that's true. Scientists are under constant pressure to publish, with tenure and funding on the line. And to get published, it helps to have results that seem new and striking, because scientists know nobody is publishing a study that says nothing up with acai berries. And to get those results, there are all sorts of ways that, consciously or not, you can tweak your study. You could alter how long it lasts, or make your random sample too small to be reliable, or engage in something that scientists call p-hacking. That's p-hacking with a hyphen. P-hacking is very complicated, but it basically means collecting lots of variables and then playing with your data until you find something that counts as statistically significant but is probably meaningless. For example, the website 538 surveyed 54 people and collected over 1,000 variables, and through p-hacking the results, was able to find statistically significant correlations between eating cabbage and having an innie belly button, drinking iced tea and believing Crash didn't deserve to win Best Picture, and eating raw tomatoes and Judaism. You don't even need to engage in these kinds of manipulations to get results that don't hold up. Even the best designed studies can get flukish results. And the best process that science has to guard against that is the replication study, where other scientists redo your study and see if they get similar results. Unfortunately, that happens way less than it should.
Replication studies are so rarely funded and they're so underappreciated. They never get published. No one wants to do them. There's no reward system there in place that enables it to happen.
Exactly. There is no reward for being the second person to discover something in science. There's no Nobel Prize for fact-checking. Scientists themselves know not to attach too much significance to individual studies until they're placed in the much larger context of all the work taking place in that field. But too often, a small study with nuanced, tentative findings gets blown out of all proportion when it's presented to us, the lay public. Sometimes that happens when a scientific body puts out a press release summarising the study for a wider audience. For instance, earlier this year, a medical society hosted a conference at which a paper was presented comparing the effects of high and low flavanol chocolate during pregnancy. If that sounds narrow and technical, it was supposed to be. There wasn't even a control group of women who didn't eat chocolate, and the study found no difference in preeclampsia or high blood pressure between women who ate the 2 chocolates. So there is no way a study that boring can make it to television, right? Well, wait. Because that medical society issued a press release with the much sexier but pretty misleading title, The Benefits of Chocolate During Pregnancy. And because most TV producers just read press releases, this happens.
Turns out if you're pregnant, eating 30 grams a day of chocolate, that's about 2/3 of a chocolate bar, not the whole chocolate bar, could improve blood flow to the placenta and benefit the growth and development of your baby, especially in women at risk for preeclampsia or high blood pressure in pregnancy.
Except that's not what the study said. It's like a game of telephone. The substance gets distorted at every step.
The information trail is a bit like a Chinese whisper. As a piece of information gets passed along, it can get distorted. It could be because of a misunderstanding, or it could be intentional misrepresentation. The only way to be sure of how the information started out is to go in the opposite direction and follow the trail back to its source. Now, we can't do this with everything we hear, or we'd be hitting the books 24 hours a day, but we should be able to spot something that's a bit fishy. Again, in science, unlike history or economics, spotting something fishy is very easy. If a newspaper not renowned for fact-checking or accuracy makes a claim that's completely at odds with current scientific evidence, then either scientists are stupid, or they're lying, or the newspaper's got something wrong. The internet is a great tool for tracking information back to its source and finding out how it's been altered. But it's also good at disseminating bad information to millions. It's rather like a screwdriver. You can use it to take apart a complex bit of machinery to see how it works or why it's gone wrong, or you can stick it in your ear to see how far it goes before it meets resistance. Our willingness to drive screwdrivers into our brains rather than unlock the truth has led to a culture of gullibility that's astonishing in even the most intelligent writers.
To be fair, it's not always the news media. Sometimes researchers themselves will oversimplify the science. And there is no doubt some of this is on us, the viewing audience. We like fun, poppy science that we can share like gossip, and TV news producers know it. That is why you constantly hear stuff like this.
Men, listen up. A brand new study says a woman is more open to romance when they are full, opposed to being hungry.
Okay, but you should know that study involved only 20 women. And you cannot presume that 20 women can speak for all women. And then there was this eye-catching report from just last year.
A university in England says drinking champagne every week may help delay dementia and Alzheimer's disease. They say only 1 to 3 glasses a week, not a day, a week, can be effective for your health.
It's fantastic news.
No, it isn't. No, that study was performed on rats. And how do you not tell people that? While studies performed on rats and mice are undeniably useful, their applicability to humans can be limited. The overwhelming majority of treatments that work on lab mice do not wind up succeeding in humans. You can see just about all of the problems that I've described, plus one more, in a study that made the rounds last year.
A new study claims that driving while dehydrated is just as dangerous as driving drunk. Researchers say drivers who drank just 1 ounce of water per hour made the same number of mistakes on the road as those over the legal limit with alcohol. Doctor, when I heard this, I thought this cannot be true.
Yeah, obviously it couldn't, because it wasn't true. As Britain's National Health Service had already pointed out, that study was riddled with red flags, including that it was based on just 12 men, of whom data was only reported for 11, and it got funding from the European Hydration Institute, a foundation that has received over $7 million from Coca-Cola, a company that just happens to sell rehydration. Look, just because a study is industry-funded, or its sample size was small, or it was done on mice, doesn't mean it's automatically flawed, but it is something the media reporting on it should probably tell you about. And you may think, well, hold on, where's the harm here? But I'm not so sure about that. Because think of it this way. This is a chart mapping the results of studies of things like coffee, eggs, and wine. All of them have been linked to raising or lowering your risk of cancer, depending on the study. And everything causes cancer is not the conclusion you want to draw from science. If I were to tell you about each of those studies in isolation, at some point you might reasonably think, well, no one knows anything about what causes cancer. And that is a problem, because that's the sort of thing that enabled tobacco companies for years to insist the science isn't in yet. And if you think I'm exaggerating about the impact that this misreporting can have on our faith in science, look at an example from...
A lot of studies that we love around here. There have been a couple, especially related to women, about the benefits, as I get all serious, on whole milk. Hey, whole milk, but it's true.
Well, there's a lot of research, though, that says actually having whole milk or having whole fat dairy products actually can help you lose weight.
I think the way to live your life is you find the study that sounds best to you, and you go with that.
No! In science, you don't just get to cherry pick the parts that justify what you were going to do anyway. That's religion. You're thinking of religion. That is what you're thinking of there. And look, this is dangerous. This is really dangerous. If we start thinking that science is a la carte and that if you don't like one study, don't worry, another will be along soon, that is what leads people to think that man-made climate change isn't real or that vaccines cause autism, both of which the scientific consensus is pretty clear on. Science is, by its nature, imperfect, but it is hugely important, and it deserves better than to be twisted out of proportion and turned into morning show gossip.
Science is often seen as a difficult subject, and yes, it is, because it's detailed, meticulous, and demands the highest possible accuracy. But those qualities also make it very easy to check. There's a mechanism for documenting facts that has survived for 200 years and has given us all the technological achievements we enjoy today.
Peer review is very important to make science credible. The authority science can claim comes from evidence and experiment, and an attitude of mind that seeks to test its theories to destruction.
We measure scientific progress in our ability to reduce the uncertainties, and by that measure we're making extraordinary progress.
But there may be a problem in the way those uncertainties are communicated to the public. Scientists may not be willing enough to publicly discuss the uncertainties in their science, or to fully engage with those that disagree with them, and this has helped polarize the debate. Searches on the internet do not differentiate between thoroughly researched evidence and unsourced, uncorroborated assertion. Conspiracy theories compete on level terms with peer-reviewed science.
Things are a little different when you have a denialist or an extreme skeptic. They're convinced that they know what's going on, and they only look for data that supports that position, and they're not really engaging in the scientific process.
I think some extreme skeptics decide what to think first, and then cherry-pick the data to support their case. We scientists have to acknowledge we now operate in a world where point of view, not peer review, holds sway.
Biologist Sheila Patek has faced political criticism for her research on mantis shrimp and trapjaw ants. In recent months, members of Congress have called her studies a waste of taxpayer money.
Some years ago, I presented my lab's discoveries to a group of leading thinkers and public figures. We discovered that mantis shrimp use hammers equivalent to the mass of 2 toothpicks and move them with the acceleration of a bullet to pulverize thick snail shells. We discovered that tiny trapjaw ants close their jaws with 100,000 times the acceleration of a sprinting cheetah. I expressed the wonder of these discoveries as well as their fundamental significance to physics, evolution, and the limits of current engineering capabilities. A prominent lawyer from Nigeria who was in the audience that day approached me a few days later. Her first words to me were, "Your research disgusted me with such waste, studying trivial and useless problems." In that moment, she had voiced my most vulnerable thoughts, that the science to which I dedicated much of my life was actually pointless. But, she added, I realized something important, that science is about discovery, not just about solving human problems. She then spoke a phrase that has stuck with me through the years. She said, "I want what you have for my country." In her country, Nigeria, there was simply no infrastructure for this type of discovery-based research. In fact, many solutions to human problems begin in a scientist's laboratory. Did you know that some of the most significant medical breakthroughs for the human brain began with research on sea slugs? The value of my work came under attack again when Republican Senator Jeff Flake featured it in a waste book. That's a partisan report that highlights what some in Congress see as wasteful government spending. They ridiculed a research project in my lab that showed how mantis shrimp use their lethal weapons to resolve conflicts without killing each other. But if you think about it, this is a fundamental question for any animal or human system that has lethal capabilities. In response to the waste book attack, I was invited to present my research on Capitol Hill. Senator Flake came to the event and I spoke to him one-on-one. I told him the story of one of the many unanticipated paths from my lab's discoveries to human applications. I explained how the extraordinarily intense impacts of mantis shrimp hammers inspired engineers to make new materials. One day, this might result in lightweight, impact-resistant sports helmets and military armor. He actually seemed engaged, so I asked him, did any of my research seem worthwhile? Senator Flake said yes. He was especially interested in the novel engineering products. These fundamental discoveries and their potential for translation are why my research program is funded by the Department of Defense and the National Science Foundation. However, engineering-related applications are not the primary reason we do this research. The nature of discovery is that it is impossible to anticipate what you'll find. That is discovery. Discovery-based research is most fruitful when new knowledge is sought for its own sake.